working as assistant professor in Department of Civil Engineering, Walchand Institute of Technology, Solapur. Today we will discuss geosynthetics and its types and functions. Learning outcome: at the end of this session, students will able to apply the suitable ground improvement techniques by using geosynthetic material under footing in difficult soil. First, what are geosynthetic? Okay, here two words are there. One is geo. Geo is soil, rock or other geotechnical material. Okay, then one more term is synthetic. Okay, and this synthetic is man-made or by using polymeric material. Why we use this geosynthetic material? Used to enhance, augment and make a possible cost-effective construction. In geosynthetic materials, we will use some polymers like by using some raw material. Okay, then types and its material. First one, polypropylene, polyethylene. Again, in polyethylene, we are using some different quality. For example, HDPE, LDPE. HDPE means is high density polyethylene, then LDPE is low density polyethylene. Third one, polystyrene. Fourth, polyvinyl chloride. Polyamide, for example, your nylon material. In nylon material, in polyamide is present. Then last one is polyester. Different types of geosynthetics materials are there. Okay, so first one is geotextile, geogrid, geonet, geomembranes, geosynthetic clay liners and geocomposites. Some other geosynthetics materials like your geopipe, geofoam, geocell and geomesh. First, we will discuss one by one different types of geosynthetic material. In that, first one is geotextile. Okay, and this geotextile is very flexible. Then high textile like fabric material. Majority are this geotextile is made up of by using polypropylene fibers. Okay, then in woven, again we are classifying two types. In geotextile we are classifying two types. One is woven geotextile, then second one is non-woven geotextile. Okay, and this geotextile is controlling the permeability. Okay, and this characterized by open and porous structures. Okay, and this geotextile is controlled by permeability. Okay, then in geotextile we conduct some different tests like mechanical and hydraulic properties. Then very versatile in their primary function. This is main function is liquid barrier. And this one is geotextile materials. Okay, and this first one is non-woven geotextile, then third one is this one is non-woven geotextile and this one is woven geotextile. Second one, geogrid. Okay, this geogrid is very stiff and flexible polymer grid. Okay, so it this geogrid is shaped in grid shape like your sheets. Okay, and this geogrid structure allows for soil strike through. Again, in geogrid we are using two types. One is bidirectional, then second one is unidirectional. Okay, in bidirectional is equal strength in both the direction. For example, your x and y direction. Okay, and the x and y direction, it produce the equal strength in both the direction. But in unidirection is only main strength in machine direction. For example, only x direction. Okay, so and this geogrid is focuses entirely on reinforcement application. Okay, and this geogrid is planar reinforcement. Okay, main applications are retaining wall. Okay, then steep slope, base and foundation reinforcement. Okay, these geogrid types. Third one, geonet. Okay, and geonet are made from high density polyethylene, then result in parallel set of ribs as a integral unit. Then again GeoNet we are classifying two types, one is biplanar and triplanar. Okay, then basically this GeoNet is using main function is drainage function. Okay, then biplanar is used in flow is equal in all direction, then in triplanar flow much is greater in machine direction. So this GeoNet is surfaces must be covered usually in GeoNet like your geotextile. This is your GeoNet. Next one, geomembrane, and this geomembrane is impermeable sheets like your 10 raised to minus 11 to 10 raised to minus 13 centimeter per second your impermeable sheet. This geomembrane main function is containment, like your basically you are this geomembrane you are using in municipal solid waste. Okay, under municipal solid waste represent as a barrier to liquids and gases. Okay, and this geomembrane is made up of HDP, high density polyethylene, and low density polyethylene or PVC, etc. And new applications in hydraulics and private development. GCL, geosynthetic clay liner. This geosynthetic clay liner function is always containment. Common product is bentonite between two geotextile. Okay, it is a sandwich between two geotextile. Okay, then internally reinforced by needle punched or stitching, like this stitching. Then bentonite product bonded to geomembrane is also available. Okay, then many other variation is exist. Competitive with compacted clay liner. Beneath a geomembrane, one has a composite liner. Okay, then again in geosynthetic different functional requirements like your separation, reinforcement. Okay, we will discuss one by one functional of your geosynthetic material. Okay, so first one is separation. Okay, so separator helps prevent intermixing of poor in situ soil with good quality granular material when a structure is subjected to surface loading. You please observe these two diagrams. Okay, this first diagram without reinforcement, then second one is with reinforcement of your geotextile. Okay, so this separator is helps to prevent the intermixing in poor in situ soil with the good quality of granular material. Okay, so it act as a barrier to migration of particles between the two dissimilar soil. Second one, reinforcement. Okay, if you geotextile is act like a reinforcement. The soil reinforcement function ensures improved response of soil to loading. Okay, then what will happen? It increases normal loading and reduces the shear forces. Then as a result, steep slope can be constructed or an embankment of increased height be built on soft soil. Otherwise would not have been possible. On pavement, geosynthetic owing to their membrane action which induces tensile forces control deformation significantly improves their performance. Okay, here this is without reinforcement and with reinforcement, and this load is transferred to beneath the this is distribution, this is stress distribution. Okay, and this is your subgrade. Okay, and base, then this is your asphalt layer. Okay, then tendency of aggregate to displace is laterally. Okay, so if in case I place one geotextile here, okay, in between base and subgrade. Okay, in that time your load distribution is equally. Okay, third one is filtration. Okay, geotextile allows the movement of liquid across plane of geotextile while retaining the soil on the upstream side. Okay, to achieve this, the material should meet the condition adequate permeability, requiring an open fabric structure. Okay, the long term soil to geotextile flow compressibility is also important, in that the filter must not clog excessively during its lifetime. Fourth one, drainage function. The drainage function of the geotextile enables flow in the plane of geotextile. Okay, apart from geotextile that transmit fluids, nowadays there are some specific products for minimize the drainage condition, such as geonets and drainage composites to meet drainage requirements. Then geosynthetic drains have been successfully in many cases, since they reduce the consolidation process in time in soft soil. Okay, for example, you can observe this typical cases. If in case your rainfall water is percolate through asphalt layer, then is transferred to your base, then again it transferred to your subgrade. What will happen? That complete subgrade is lost when you apply the some stresses. Okay, then in that time I will will reinforce one geonet or any geotextile. Okay, so it holds the transferring water subgrade to base layer. Okay, so this is the main drainage function mechanism. Then barrier function, the barrier function using geomembrane and geotextile clad with bitumen, rubber bitumen or other polymer mixes is useful in many applications for minimizing fluid and vapor flow. Okay, this barrier function, to minimize the barrier function, we will use the geomembrane or geotextile clad with bitumen or rubber bitumen. The fluid permeability of material is very low, and it's therefore useful in many applications such as canal lining, dams, municipal waste landfill, etc. The applications etc. is therefore useful in many applications such as canal lining, dams, municipal waste landfill, etc. This is the we will use the geomembrane in steep slope, and this main function is barrier function. These are some references. Thank you.